So this session's penultimate presenter is GSWA Manager for State Geoscience, David Martin. David is responsible for the collection and maintenance of our statewide geoscience datasets, and he's talking to us today about the integration of isotopic and seismic data in the Yilgarn and the Pilbara Cratons.
Right, thank you, Michelle. And before I start, I'd like to acknowledge the traditional owners of the land on which we meet today, the Whadjuk people of the Noongar Nation. I'd also like to acknowledge some of my co-authors who I'll have to admit did the bulk of the preparation of this talk for me while I was in the field. Klaus Gestner, our Chief Geoscientist, Hugh Smithy is responsible mostly for the geochemical aspects of what I'll talk about today, Yongjun Liu for the isotopic component, and Ruth Murdy in the WARA team for the passive seismic. So GSWA, a lot of the work that my branch does has been based, over the last 135 years, our work is based primarily around outcrop mapping, but as you will have heard from a number of different talks today, we're moving at a rapid pace into the deep lithospheric domain. And this talk today is about integrating a number of different data sets that we use to compile sort of new maps on the lithospheric scale. And John this morning provided a very good introduction to this first slide, which is the study of Hoggard et al. In 2020 in Nature Geoscience, which showed the importance of major lithospheric scale boundaries in the localization of mineral deposits. And that's kind of the main reason why we're sort of heading down to this deeper lithospheric space. It's primarily mapped from geophysical data sets, and coincidentally at the time that paper came out, we were in the beginning stages of the Accelerated Geoscience program, and Ruth and I were compiling this major crustal boundaries map and 3D model of the state, which then subsequently, with the collection of more sort of geochemical and isotopic data, is starting to show that there's quite a good correspondence between these data sets. And of course, the reason why the geochemistry and the isotopic data is so important is it starts to give us some handle on things like crustal melting depths, and the processes that have gone on through the lithosphere to bring mineralisation to surface. So in terms of how that 3D model and map of the lithospheric boundaries was compiled for the AGP, we started off by looking at active and passive seismic sections to constrain the location of individual crustal boundaries. And then these were extrapolated using potential field data, mainly gravity, because it's looking at the deeper crust, to produce the map that you can see there, the grey lines are the major crustal boundaries that were interpreted. But at the same time, we were also looking at the isotopic data, and the isotopic data maps the age of continental crust formation, and as you can see, there's quite a good correspondence between certainly some of these boundaries and the isotopic data, which nicely picks out the cratonic regions of the state. So starting with the principal data set that we used for compiling that model was the active seismic, which is of course very good for imaging the relatively shallow levels of the lithosphere, mainly down to the MOHO depth, but the important thing is it also highlights the major crustal boundaries which offset them, by definition, offset the MOHO, and those are the boundaries are marked in pink on that slide. The other data set is the passive seismic. This is the coastal passive seismic, Canning coastal seismic line. The importance of the passive seismic, as John pointed out this morning, is we're imaging to much greater depths in the lithosphere, and certainly below the MOHO, and with WARA, of course, we're hoping to go even deeper than that. Of course, this is just a 2D section, and WARA is going to provide us great data in 3 dimensions. So in terms of integrating the lithospheric architecture with isotopes, the 2-stage depleted mantle model age maps are updated annually, so I encourage you to download those each year to get the updates. This is the whole rock Sumerian neodymium map, which outlines the Archean cratons versus the younger tectonic units. And the thing that's come out of this is the identification of this region of very young crust wrapping around the West Australian craton. When we integrate that with the crustal boundaries, like I mentioned before, we can see that the crustal boundaries are reflected quite well in the isotopic data. And these boundaries are commonly inferred to localise various styles of mineral deposits, and traditionally we would have looked at things like gold, copper, and of course the flavour of the month right now is our friend lithium. You will notice from some of those trends that these major crustal boundaries that we've mapped based on the seismic, there's other structures that appear to exist almost at an orthogonal arrangement to those boundaries. And these structures have turned out to be quite important, we think, for the localisation, particularly of lithium-bearing pegmatites. So if we look at these boundaries, the two zones that have been identified is this Q isotopic zone, which is a zone of younger lithosphere within the Yilgarn, and then there's this southern high strontium yttrium zone, also characterised by slightly younger crustal or sort of mantle extraction ages. And then on the right-hand side of that diagram, we've got the gadolinium ytterbium contours based on the granite database. And this is showing quite nicely that it also mirrors these, I'm going to go back, mirroring these trends that we see from the isotopic data. The interesting thing, of course, is the majority of that granite data is older than about 2.7 billion years. And so what the granite data is showing is that these crustal boundaries here that are been interpreted as being due to accretion of terrains onto the eastern side of the Yilgarn, those boundaries are not overprinted or don't overprint these geochemical boundaries. So the interesting thing with integrating all this data, then the SWAN array that John was mentioning this morning, this is the very preliminary coarse model of the SWAN array based on an irregular grid. We can see that particularly in the deep crustal levels, that same trend is coming up, suggesting that perhaps there's some really deep lithospheric control on some of these granite trends and geochemical trends. Of course, the WO array data is on a much higher density, 40 kilometre grid, and hopefully in the future we're going to be able to refine these models a lot more and have a much more detailed understanding of the 3D architecture of the lithosphere. And then something else I just wanted to give a promotional plug for, in addition to the passive seismic, we've also got a program of active reflection seismic on the go at the moment, funded through the EIS. There's three lines within this program. We've got the Southwest 1 line here, which is an extension of one of the Albany-Fraser lines, and that's taken that line from Cascade all the way out to Hamlin Bay. That seismic line acquisition finished on the 30th of October and was run by HiSeis. They're in the process now of doing the data processing, and next week they'll be starting the Midwest 1 line up here, running from Mount Magnet out to Geraldton. Again, that extends westward an old GA line. And then early in the new year, we're going to be acquiring the Midwest 2 line here through the Perth Basin, just south of Geraldton. So the take-home messages is that based on the broad correlation of inferred lithospheric architecture between seismic, isotopic and geochemical data, this data acquisition is ongoing, both active and passive seismic. Something I haven't mentioned, but John mentioned this morning, the magnetotelluric data. We also got ongoing isotopic and geochemical data acquisition, and particularly reanalysis of old samples for some of the critical elements that were not analysed historically. And the integration of all these data sets will inform better regional mineral systems analysis and targeting in future, a role that will be taken up by the branch that Simon mentioned this morning on that will look at data systems or data integration. So thank you.